Thank you. Hi, Balkon. Nice to be here again. Hope that the previous presentation was really interesting, and this one is also interesting, but I like the previous one. I first see that a car can be really hacked that easy. Of course, I knew about that, but I first see this on the presentation. Okay, so I will be presenting interesting methodology, which is new of its kind, methodology for vulnerability research and exploit development. So many people do vulnerability research and do exploit development, but they do the hard way at the beginning. And everything at the beginning is hard, and after that it becomes easy. The point for this methodology that I have developed is to get directions for hackers, get directions for vulnerability researchers very easily to do their job, and automatically to have faster result, because as fast as we get the result, fast as we get the bug, the vulnerability, then it means that we can make the device, the target, safer in no time, because the vendor will develop a patch very easily and very fast then. So there is a lot of bugs that are happening nowadays, a lot of bugs that are discovered, and many of them have been used inside ransomware also. So we get that WannaCry this year, which didn't do any damage in a way of financial damage like the previous ransomwares, but it did use a vulnerability that was discovered by NSA, and it was released publicly by the whistleblowers. So World of Bugs defines that we, as hackers, ethical hackers, vulnerability researchers, need to pay more attention on this and find more and more zero-day vulnerabilities inside the targets, web applications, desktop applications, cars, drones that fly, and everything, Internet of Things device. So finding those vulnerabilities can help this place, this internet, this world to be a safer place. So what you need to know in order to find a vulnerability, and how difficult it is to do that. At the beginning, the difficult thing is to learn the technology that is used inside the target application, inside the target system. So learning the technology is something that we have to do before we approach to vulnerability research. Learning the technology can be done in very simple way. You can download a course about that technology and realize how it functions, but many of the technologies that are used inside, for example, Internet of Things, is not public. So we need then to go furthermore, one step further, and to find those books, to find those information, to learn about that technology before we approach the vulnerability research. Then we need to use hacking tools. The previous presentation showed this HackRF, which is really good hacking tool developed by this Hack5. So it's really interesting American organization for hacking. So they developed these hacking tools like this HackRF that the previous presenter demonstrated. So learning those hacking tools is a must for vulnerability research. Then we have the choice of the right method to approach. Well, if you approach, for example, directly on a web application in a way that you do automated scan, you will be immediately detected, and maybe in some case you will have problem with the police. Like if you do automated vulnerability scanning on public IP address which belongs to USA, you have problem with FBI. That's normal. So you have found the approach the right way. So you go in manual testing, for example. So what's next? So the next thing is how to justify your time that you do the vulnerability research. For example, if you work for a company and the company pays you a salary, month salary, so you need to justify your time. For example, if you find a bug, how much money you will get from that bug. So in some cases, you might get some money, of course, if there is this bug hunting program by the vendor of the target that you are testing, but in some cases there is no money returned, just a thank you from the vendor and your name, your nickname in Hall of Fame. So after defining how much money you will earn, let's see how much money should I spend. So all of these hacking tools, techniques, like for example, if you use the debugger or the decompiler from Hexray, either Pro, so they are about 3,500 euros. So that's the beginning suite of those debugger and decompiler that you need. So it's not really cheap, 3,500 euros. So you need to define all of those hacking tools, you define the budget, and then you will go further and do the real vulnerability research. At the beginning, it will be really, really difficult because you must go and do all the techniques, all the activities that you have prepared again and again and again. You will have a lot of mistakes, but you will learn from that. Like in information technology infrastructure library standard, you have the base, the database of known solutions for known problems. The same thing in vulnerability research methodology we do. We build a database of known techniques for known problems. So based on the approach that we have, we might identify a certain problem, and then if from the previous research we have successfully done that, solved the problem, the same problem, then we go to that database and find the technique, the solution for solving that problem. So the methodology that I come up with during the analytics and doing vulnerability research and analyzing everything that I can get a hands on, I developed this methodology in 5 phases. So approach method, way to find a door, first doorstep activity, ending infinity, and engineering the exploit code. Basically, the approach method at the beginning, yes, don't forget to get a lot of coffee. Yeah, that's what you need. Get sleep, get coffee, or if you don't want to get sleep, get coffee and get some pills to make you really, really aware of what you're doing and full of energy and with focus normally. So let's go on the first phase. The approach method, it's vendor dependent mostly, meaning that if you want to do an use of automated tools, then it will be loud, it will be detectable, and immediately you should know that it will be not efficient. So we are not 90s. This is 2017, so many targets that we test for vulnerabilities, for bugs, already have used the best practices to make it safer as a solution. So those automated scanning tools are automatically non-applicable, so they will get a lot of false results. They will say that it's secure, there is no bug there, no vulnerability, but unfortunately, that's not true. So the vendor says that he needs a manual testing. Then we go into manual testing. Manual testing is really time-consuming. Of course, it needs big intelligence, so we need to identify the logic. We need to identify what really happens, know the business, and then do step-by-step approach, executing all the activities that the target has, all the functionalities that the target has. So manual testing is also very quiet. So it's not detectable in many cases by the IDS, IPS systems, so it cannot be prevented. By doing penetration testing projects, in the past, we learned that we can make detection on manual testing very easily if we identify abnormal behavior of the target system and set that abnormal behavior as a trigger to raise an alarm in the CM solution. Then after identifying the approach, we go to the next method, way to find a door. So way to find a door is possible with one option, but I recommend to try all the options listed on the slide here. So the first one is the enumeration. We discover the inputs, all the inputs. Of course, who has done here a web application enumeration? Okay, a lot of guys. Okay, great, great. So discovering the inputs on web application is easy. But what about the inputs inside a binary desktop application? What about the inputs inside a running operating system on a car? So they might be different, but think outside of the box. Always get an approach that will have possibility to identify more and more inputs by thinking outside of the box. As I said, discover the activities, list the activities. So always have with you on paper to write down all the activities that you have discovered. Then discover the surface. Then you go in thinking. Thinking is option where you do this analytics, how the program, how the target is functioning, identify the hidden opportunities. Like, for example, the hidden opportunity inside a car that is to drive forward in second gear. Like, for example, why not that information, as much as simple as it looks, it's a hidden feature inside the operating system in the smart car. So then through that hidden feature, you might bypass a certain features in the operating system on the smart car that analyze every single input. Like, for example, in the elevator, you have this in the elevator option to press a button to go to a certain floor. And there is this elevator device that figure out is somebody inside the elevator by analyzing the weight of the floor. So then you press the button, you get out, the door closes, and automatically, because the analyzer of the weight of the floor on the elevator shows that there is nobody there, no weight there, so automatically it will disable the command to go to the certain floor. But if you get in and if you press the button, if you get out and while the door closes, you just make the door to stop closing by pressing, putting your hand on the sensor that somebody is on the door, so the door will again open, and then put the door behind and leave the door to again close, but don't get inside the elevator. So then in that case, in doing this, you will bypass the control that the floor weight sensor, the floor weight sensor in the elevator is receiving. So bypassing that means that now the door closes, and with empty elevator, the command for going to a certain floor will execute. So you have bypassed the control. So it's really interesting way, but that is only possible by thinking. So this can be applied to any kind of target system, web application, desktop application, operating system, anything. So next thing is diffing. Identify differences. Differences is something that is, if you have done any diffing on a patch released by Microsoft, you know what this thing means. But the diffing can, in many cases, analyze the differences between two versions. Let's say that you have this web application, desktop application, version 1 and version 2. So you then do diffing to analyze what are the differences in the code, differences in the commands, and analyzing the differences, you will find a hidden feature which is disabled by default in the second version, but you can enable it because you have found that piece of code by doing diffing. Discover how they differ, and it's really time consuming. So for doing diffing, you need, first of all, you need the right tool. Second of all, you need very, very, very long time, and of course, a lot of coffee. Yeah. So next is first doorstep activity. So we find these inputs. Okay, now what to do? How to find the vulnerability? Are those inputs, are those activities, functionalities of the target system vulnerable? So we can use this brute force, hapax, or inconcatenation. So brute force is classical. You are hackers, we all know. We can use fuzzing. But brute force is very easily detectable by the IDS. So it's very loud, and it is really, really easy detectable if there is the security control in place, and it might get you out of the way of finding really a vulnerability. So brute force is not the right approach. But in some cases, it could be the interesting approach that let's say that you identify that there is no security control, then it can be interesting approach of discovering on Stack Overflow, buffer overflow. So doing the smash of the application with this brute force with fuzzing is really powerful, but only in a case if there is no security control on that input. The hapax is a unique activity that happens only once. So it's related with the business logics. So you have to know the business logics in order to do that and identify all of those possible hapax activities that can be executed. Like, for example, you can change in the business logic, there is feature that you can change your profile only once a month. So that's a hapax. So you can change the profile once a month. So that's a hapax activity that can happen only once. So next thing is you wait 1 month to continue with your research. Inconcatenation is predefined set of activities, which is setting a script to execute manually a lot of activities to get you to the place where you want to be. Like, for example, you built in a desktop application for financial work, you built a project that has a lot of documents needed, a lot of information needed in the database to generate a report. So you use inconcatenation, a lot of predefined activities to build that in order to get to the function generate the report, which is the end that you want to test. Then smart fuzzing is also here. Smart fuzzing can be done with a lot of tools. You can use automated tools. You can use smart fuzzing with, like for example, in web application, you can use smart fuzzing with scripts in Z-Attack proxy. Z-Attack proxy is a really good proxy tool for open web application security project that is widely used by hackers and vulnerability researchers. So from this phase 3, we built 2 databases. One is discovered vulnerabilities. So if we discover some vulnerability doing these activities, and the second is target door entries tested without outcome. So there is nothing happening, no discovery, no finding from them. So we go on the phase, of course I have to say this, I became insane with long intervals of horrible sanity. Yeah, when you do vulnerability research, you waste a lot of time, you might find nothing, but don't say that because you have discovered new techniques, new ways to solve some problems, to do something that builds your database of knowledge. So the next time you approach, you already have this knowledge and it will be very fast. Okay, next is in the middle of every difficulty lies an opportunity. So what happens with those doors that we have discovered and that we have tested and there's no result, no vulnerability, no finding? So the next step is ending infinity. In ending infinity, we have this lucky choice, bonanza or breakdown. So bonanza is like, for example, you get out in Friday, get a couple of beers, get a good sleep in Saturday, go out hiking in Sunday, and in Monday morning, you have a completely different set of thoughts in your head, and boop, it comes up with a solution of the problem, and you find a vulnerability there. So time solve problem. Look for different point, and of course new ideas and techniques. That's why we're here, to learn something new. At the end of the slides, I will show you a hands-on example how to find a vulnerability, a couple of techniques, approaches to find a vulnerability inside a desktop application. And breakdown means let's see what we have done so far. Let's identify, review the logic. Let's see, like for example, we have this target banking application. So in the banking application, you focus on issuing a new credit feature inside. So accidentally, or I don't know, maybe it's not looking right in the application, you jump over a certain function. So then you go back in this breakdown and you analyze it again, and you identify that in that feature in the banking application, there is a new attribute that was not tested by you. And the attribute is unlocked if you choose from a certain field drop-down menu, if you choose a different value. So you see a new attribute now because you have breakdown the previous steps. So you then test that new attribute, means that you go back in the previous phase to test the first door step activity phase, to test this, and if you find any vulnerability on that new attribute that you have discovered in breakdown, boop, boop, you are successful in your project. Okay, in some cases, repeat previous steps again might disclose possibility for finding things like a new entry point, in the feature that you have fulfilled with information from the previous steps, but because you haven't go back and to check the feature again, you have checked the feature before you input the data, and you have seen nothing, and then you come to this phase 4 in breakdown, and you repeat that activity, go back, let's check again that feature. Does it have any data inside that form? So yes, there is data, there is possibility, a new attribute appears, and then you go again to find a vulnerability there. Okay, so the phase 5 is after we end with everything. We found a vulnerability, so we need to develop an exploit, a defined way to breach that vulnerability in order to have proof of concept, or of course to develop an exploit and sell to NSA. Yeah, of course. You get a lot of money there. I'm just kidding, no money there. Okay, so depends on the goal. When you develop the exploit, you can go in totum and parse. The goal in totum means that you develop from scratch. It's a unique exploit that you have developed for that vulnerability, and nobody has that code. Nobody can reuse that in his, let's say, penetration testing toolkit like Metasploit or Core Impact. So it's your exploit, and only you know how this thing works. Then opportunity to sell it, there is. To sell it to penetration testers that will use that piece of code to do penetration testing project. And of course, you cannot get rich from that, but you can, of course, contribute to higher security, because those penetration testers with discover of that vulnerability and use of that your totem exploit as a proof of concept will convince the vendor, the target company, that there is a vulnerability and they need to get that vulnerability fixed immediately. So parse means that you are running out of time and you need immediately to change that. And then you develop an exploit with use of features in Metasploit, and you develop the exploit as a module in Metasploit, and everybody can use it, and then you go in and release it in public. Of course, if you release in public an exploit from Metasploit for 0-day vulnerability, then that is really, really bad, because you do not contribute to security. You contribute to more hacking attacks, successful hacking attacks. So first, before developing and releasing an exploit for 0-day vulnerability inside Metasploit, publicly, of course, contact the vendor, try to get the vendor to release a patch before you really release this hacking tool, because this exploit will be at the end a real hacking tool, really dangerous one. Okay, so these databases, exploit module and unique exploit come up from phase 5. This is a diagram view. You cannot see anything here. No? Okay, so great, I will zoom. Okay, you can see now. Okay, great. So at the approach method, to avoid detection, yes, no, the question, the vendor choice, give us to go in automated testing or manual testing. Approach method is also in automated and manual testing based on the knowledge that you have, tools that you have, techniques that you have learned for testing. Then in the way to find a door, we have this enumeration, thinking, and diffing that we talk about, and all of them come up with the result, a target door entry. So we now have that target door entry, and we go to the first doorstep activity. In the first doorstep activity, we get possibility with the use of this option, brute force hapax and inconcatenation, to build this database of discovered vulnerabilities, and of course, database of target door entries that are just a dead end. But really, are they dead end or not? Do not get your hands off the entry door until you have exhausted all of the possible opportunities to identify vulnerability there. So that is ending infinity. And if you also exhaust every single thing, then go and do target door entry dead end. Just put that information inside the database that this is a dead end. So nothing can get out from that. And of course, engineering the exploit code. You have seen on this diagram that there are a couple of things links between databases, links between phases in which you go from phase 1, 2, 3, 4, 5, but a couple of phases can get you back to the previous phase. Like, for example, here in discovered vulnerabilities in the ending infinity, you might discover a new vulnerability that can open a solution inside the target system that you have not tested yet, because it was not visible in the previous steps. Now it's visible. So that's why in the discovered vulnerability, you go back, or yeah, here we are. You go back here, and you go and wait to find a door. Go to that new solution that you have discovered, and do again enumeration, thinking, diffing. You might discover a new target door entry then. And if you discover a new target door entry, go again in the first doorstep activity to find that vulnerability in that target door entry. And of course, from first doorstep activity, here, in discovered vulnerabilities, yeah, I showed that. So, yeah, that was the back. Okay. So that was the diagram view. So future development and vision for this methodology is building testing wide for every element. So that will be focused mostly from the Open Web Application Security Project community, testing wide for mobile application, desktop application, web application, Internet of Things devices, and so on. So build on that knowledge. We will have this unique testing wide under the methodology for vulnerability research and exploit development. So the creating of multiple practical examples to get you a direction for new vulnerability researchers and for the existing vulnerability researchers to easily get this activity done is also the future development. And I'm in a procedure of getting the OWASP project created, new OWASP project that will be the vulnerability research and exploit development methodology that you have just seen. And hope that it will be really, really fast and it will be done this year. So next year we will have this opportunity for everybody, for all the community, for all public people to get that methodology and use it right away. Meanwhile, if you want to learn more, if you want to get immediately hands-on on vulnerability research, this is really good book called A Bug Hunter Diary. Bug Hunter Diary is not a very old book. It's from 2014. You can find it on Amazon, buy it. Of course, it's as a starting point, the best thing that you can go and do if you want to go into vulnerability research and exploit development. In the practical example that I will show, we will use a desktop standalone application, which is Point Financials. Macedonian company has developed this application. It's a desktop standalone application for Windows operating system, and it uses Microsoft technologies. And we will use basically to identify sensitive stuff, to identify possible weaknesses and vulnerabilities, sysinternal suite of tools, which is free from Microsoft, and the x64DBG open source free debugger that is really powerful. And if you are into debugging, this is something that you must use. Of course, the best worldwide is Hexray EDA Pro that you can use, of course. But this is also really powerful because, first of all, it's free. Second of all, you can develop a lot of things based on that ground. So it allows you to develop new modules, helpful scripts that the same like in Hexray EDA Pro, you can use it here. Okay, so let's go and jump to demonstration. Here we are. So we have Windows 10 here, 32-bit, on which I have pre-installed the application that we are demonstrating. And I have pre-installed tools that I will use to find specific things. First, before I go and run that, I would like to show you this table. Can you see? Yeah. It's not really so clear, but You can see this is from Open Web Application Security Project, top 10 categories of vulnerabilities. So there have been web-based and think client-based vulnerabilities. So identifying web solution and desktop application or think client, it can be standalone or a server client-oriented solution. We identify for a certain category from OWASP what is applicable. So like, for example, improper error handling is applicable for both of them. So let's go and check this reverse engineering. Number 8, it's applicable only to the thin client, only to the desktop application, or it could be server client-oriented, it could be a standalone application. So let's go jump onto demonstration. For first step, let's identify what is the application looking like. So I will run the application now. Okay, so this is the application, Point Financy. So what we can do here, we can go to the administrator, we can go and list all the users, and if we want, we can create a new user. Let's create a user test. Okay, so this user will be also administrator. So you can go and check the input fields. You can go and overview all the application manually and try, in many cases, to input something that is not supposed to be there. But what about the basic approach in testing desktop application? The first doorstep activity that is recommended is to check the process running behind, so Point Financy process, this application process, to check what it does, what kind of registry values it opens, what kind of communication with the Windows modules is doing, and so on. So to do that, we can use the sysinternal process monitor tool. Here we are. So the process monitor, by default, when you first start up, it will generally create a log of activities from all running processes. So it will jam your PC and it will reboot the machine in many cases. So of course, if you don't have enough resources on that machine. So I need to first set up here a rule which will say that the process name for us to collect logs for its activities will be process called Point Financy, then include, add, apply. Okay, so now only activities from that process will be here. So let's go and check the process. Okay, here we are. Let's check what it does. Let me first just get this here. What it does when we go and change the user. So we click here, change user, and we change the user to another. Okay, so you can see that interesting action happened, but there are a lot of activities here recorded. Of course, it will take maybe infinity for you to review all of them. So what you need to do, get the right approach. So you can see here are registries. Desktop applications are known to, in Windows, are known to use registries for storing sensitive information, to store maybe in some cases the access control IDs and so on. So what we need to identify now and filter only those activities that are linked with registries. So the activities linked with registries, it's not really looking good here, but here it says rec open key. So the operation that is done inside this column is the one that we need to identify that is linked only with the registries. And we do that using a filter. So we can use a filter here. So that will be the operation. And operation, you can set up here the filter to say that it begins with rec. So begins with rec, then include, add, apply. Okay, so now we get only those activities, only activities listed that have this registry. Of course, again, a lot of activities. It will really take a lot of time to dig inside this stuff and to find the real thing and to find maybe situation in which you can change an already created registry with a value of from 0 to 1 and then get a full admin access. So that thing can also happen. I will jump over this method because it will be taking a lot of time, and I will jump to the next method to identify the input. So the next method is to identify in the binaries with reverse engineering all the strings inside this point finance executable file. So I will use for that from sysinternals process explorer, and let's run it as an admin, so it will allow us to get access to that binary file easily to all the things. So here we are. This is the binary point finance executable. So I go right click properties, and there is this tab called strings. So this tab called strings gets a lot of interesting information for us listed. Like, for example, here you can see the SQL query, and analyzing the SQL query can identify the name of table, name of columns. So we have here a database. So if we go back to the file explorer, and if we go to local disk C, sorry, just to get this off. And inside the folder where this application is installed, we can check and see that there is this MDB file. It's Microsoft Access. So let's go and check view, file name extensions for any case. Yes, it's MDB file. So this is the database of the application, and it's locally stored. But if we want to access, let's double click. Yep, it asks for password. Yeah, we need a password now. Of course, we can use brute force method. We can crack the password if we can, of course. But the developers were really, really interesting. I have tried to crack this and to get inside, but it was without any success, because every time a hacker tries to crack and find a way to get in with brute force, he assumes that the password is minimum 7 characters long, and he starts from that point. He never checks, is the password 3 characters long? No. Yeah. So that's why it's always unsuccessful attempt. So they abandoned that technique. But let's get into this. So here you can see a lot of strings. It's impossible to try manually every single of them to check, is this the password for the MDB or not? So there are a lot of strings here. You can see a lot of strings. So what to do is to use a debugger. So let's go, close this, and this, and use the debugger. X32DBG is the x64 version for 32-bit. Okay, this is the one. And if I go and attach to the running process point finance here, and I can see a lot of interesting stuff. Of course, this is not a debugging course, but a lot of interesting stuff. Basically, the first thing that we need here is the same that we have done with Process Explorer, listing all the strings identified inside the binary of this application. That can be done right-click and using search for all modules, string references. This is basically the technique that all of the debuggers use. And then it will, in no time, identify all the strings, list all the strings here. As I see, it takes time, yeah. So I think it will be done in maybe 15 seconds. But after identifying all the strings here, next step that we will do is to identify the SQL query inside the strings that contain password. So then we can get a debugger breakpoint on that instruction where this string select query with the password is located, and then go, and when we trigger that breakpoint and look at the stack, we can then try to find, is there any password in the stack or not? Of course, I have done that, and it's dead end. So the next thing after that unsuccessful technique is to use this technique to debug on connecting string that identify connection with the MDB, with the database. So let me show you that. Come on, come on, come on. 97, 98%, 100. Yeah. Here is it. These are all the strings. And of course, there are a lot of strings. Manually analyzing them, it will take infinity. So you have this search here. So let's go and try to type password. Okay, here we are. So we have here password. So a lot of, but not so much. Not so much. You can see there are maybe 40 or I don't know 30 strings that we need manually to identify what are they representing. So here we have this select user ID, username, user login, user password from table users. Yeah, that's the one that we need. But I have identified and I tried to go there and it's a dead end. So the next step is to identify the connection provider for the database for the MDB. So that's this one here that I just selected. It's provider Microsoft Jet OLEDB 40 data source. And then we have here also password equal inside the connection string. So let's assume that when the connection string is called inside the execution flow of this binary, the connection string might also get as an attribute the password because it needs that as an input. Here we can see in this string. So let's get a breakpoint. Right click, set breakpoint, toggle breakpoint. Yep, here we are. And let's go back to the CPU here. And let's go and play this. Now it's running. Yeah. Okay, my mistake. Let's close this first. Let's open this. Let's go and open in the debugger the executable binary from the beginning, when the really connection to the MDB is done, because we already have jumped over that from previous execution of the point financing. So let's open it. Okay, great. And let's go right click. I think that we already have this inside the source thread. No, it's not. References, here we are. So here is the breakpoint. The breakpoint is already set. Let's go to CPU, and because it's in pause, it says system breakpoint reached. So let's go step by step. Yep. Okay. Run. Yep. Here is the breakpoint. You can see this. Here we have the breakpoint reached. And if you go on the view of the window where the stack information is displayed, that's the right bottom corner, you can check and see interesting information on which there is this path for the database and of course this Zen. The Zen is, you assume, the password. Zen is the password. So let's try that. So let's open the MDB. Let's go to this PC, the local disk C, point financing, and this is the MDB file. Double click, and let's try with Zen. Okay, yeah, we're in. Yeah, great. We discovered that. So here we have this table users. Yeah, here is it, table users. So this is the username, this is the user login, and the user password in clear text. Yeah, so they are really, really good in security, point financing, yeah. So I still haven't communicated with them because, of course, this is not considered a really, really big threat because it downgrades the attack vector. It's an application that is free of charge, everybody can use it. But anyway, as a countermeasure to this, our recommendation for point financing is to use a different way to build a connection with MDB on the beginning. So don't use predefined string of the connection query. Like, let me show you this one here, references. This provider, Microsoft Jet and all. Don't use that predefined. Construct that on execution. So that's the real approach. So this is something that they have done inside their code as a string input. a predefined string input. So that's why we have successfully identified and set a breakpoint on it. So it's really bad practice. Okay, so this was an example, practical example. Let's go back to the slides. So the next is questions. Any questions? Yep. There, at the end.
Okay, I have one question. You were while running an executable in the debugger, and you could see all the strings and instructions and everything in assembly. Have you encountered, let's say, PA packer or decryptor, I mean encryptor, or some tool that obfuscates the code, and you cannot see like the regular strings, but you have to unpack it somehow?
In this process, in this program, or in other programs?
In general, in general.
In general,
Yeah.
yes.
Yes.
They are.
Is it making your job harder, or?
Yes,
Yeah.
it makes it really harder, but then the stack is the one that you need to monitor.
Yeah,
Because
yeah.
those things get and construct the strings that are readable and usable by us and put inside the stack. So you can then monitor the stack while the program executes. And you can set a breakpoint to be set if certain string is identified in the stack with a regular expression. And that's, of course, an advanced approach in which you need to develop your own script that you can use inside these debuggers. There is no default script for that.
Yeah. Okay.
Okay,
Thank you.
here's a ball for you. Yeah, this is interesting open web application security project logo ball. So it's for stress while you do the debugging. Here you go. Great. Okay, other questions? I have more balls, no problem. No questions? So raise a hand. Okay, you get a ball.
Has it been done the question?
Oh, great. Other questions? Yeah? Oh, okay, it's there. Great. I don't have any more balls, but I have stickers, open web application security project stickers.
We have a real
You can come
question.
here, not a problem. Yeah, question?
What happens if you don't find an exploit in a set amount of time?
If you don't get an...
If you can't find
Only
anything,
one, yeah, only one. Two, okay.
if you can't find a vulnerability in a long time, I mean, if you get stuck,
Yeah, that's infinity. So you get into the infinity. So then you need to make up your mind. Will you get your hands off or not? But as I said, wait time solves problem. So go with your friends, get a couple of beers, go hiking, go on vacation, and in a couple of years, try back. Yeah. Okay. No more questions? Great. Thank you. Don't do anything that is unethical in your vulnerability research. Okay?